Hello guys, welcome to the channel. Let's continue where we left off with recording while I build. So today I'm just going to show the whole authentication system and explain the logic behind every line of code. Let's get started. First, we'll have to see where we initiate our session because you will see it being user a lot later. So you just have to know now how my session is configured. The session is wrapped in a function session security so that it can be called anywhere. So let's see what's inside. What you have to know is that the initSet function is a built-in function that will allow you to set configurations of the system in the php.ini file. So what we're doing here is adding or changing settings in the php.ini file. The lines have comments on them. So session.useOnlyCookies with value 1 forces PHP to only use cookies to manage sessions, meaning PHP won't try to include the session ID in URLs. This makes it safer because session IDs won't be exposed in the browser address bar or logs. Session.useTransID disables something called transparent session IDs. By default, if cookies are disabled, PHP might automatically add the session ID to your URLs, but we don't want that because it's insecure. So setting this to 0 prevents that from happening completely. Cookie HTTP only is really important. When set to 1, it makes sure that your session cookie cannot be accessed through JavaScript. In other words, even if someone injects JavaScript on your site through XSS, they won't be able to read the cookie that stores your session ID. So it gives an extra layer of protection against XSS attacks. Now here, ini set session.cookiesecure and through off. This line checks if the website is being accessed over HTTPS. If it is, it tells PHP to make the cookie secure, which means the cookie will only be sent over HTTPS connections. That way, the session cookie is never sent in plain text over regular HTTP, keeping it safe from being intercepted. Session.useStrict mode enables something called strict mode. What that means is PHP won't accept any random session ID that someone tries to send. Only IDs that PHP itself has generated will be accepted. This helps prevent session fixation, where an attacker tries to force a victim to use a session ID the attacker already knows. After that, we have the cookie configuration part it's sent. So here we're setting detailed rules for how the session cookie should behave. Lifetime is 864000, which is 24 hours, meaning your session will last a day before expiring. Path is /, which just means the cookie will be available on the whole site. Domain dynamically sets to whatever your current domain is. Secure again ensures cookies only go over HTTPS. HP only keeps it hidden from JavaScript. And same site is set to strict, which tells the browser not to send this cookie on cross-site requests, helping to protect you from CSRF attacks. Now you may have noticed that the settings are actually repeated, but like I said before, the ini-set line changes the PHP configuration globally for the session system. And now we have session set cookie params. This line applies that setting specifically when starting the session. So I use both because some older PHP versions ignored certain options in one method, so we can never be too careful. Finally, we start the session with session start. This is where the actual session starts. Everything we've configured above will apply from here on. If the session doesn't already exist, PHP will create a new one using these security settings. Next up, this part regenerates the session ID the first time the session starts. What that does is prevent session fixation attacks. It replaces the current session ID with a new one that an attacker couldn't have predicted. After that, we set a flag session initiated so that it only runs once per session. And finally, we have this last security check. What this does is stop anyone from trying to send the session ID through a GET or POST request. If someone does that, which could mean a possible attack or misconfiguration, we immediately destroy the session, send a 403 forbidden response, and stop everything right there. This ensures that session IDs never travel through URLs or forms, only through cookies. And that's it. So basically, what this whole function does is lock down how PHP handles sessions, forcing secure cookies, preventing hijacking, avoiding ID exposure, and regenerating IDs safely. At the very end, the function is called automatically, session security. So any file that includes this one will instantly have all these session security protections enabled without needing to call it manually. Now let's go to the real deal. We're going to start from the AuthController class, since this is where everything meets up. Let's start with the the constructor. We're initiating the service classes immediately. And below it, we have the singleton function. We already talked about these two and what they do in the other videos, but let's keep going. The show login form function just gives the view of the login page. Nothing big. Now we move on to the most important function in the controller, or at least the start, the login function. So let's see what it does. It starts with the error array variable that we'll use to collect errors. Then we try to get the email from the post request. Then we use our custom service class to do some validation on the email. So let's check what this MailCheck class actually does. In the MailCheck class at the top, we have a helper function called sanitize. This function checks if the email or any data was given at all. It doesn't matter what type of data, as long as it's not an empty string. Then if it passes, it goes ahead and uses filter var $email filter sanitize email. This is a built-in function, and it will do its thing to try to understand if it has a mail structure, and that includes the @ end. It's simple but helpful. Secondly, we have validate structure, which takes in the email and sneaks in the error variable. That's why it has that n on the variable. Validate structure email and all errors. This is basically like passing by reference, I think. So the first line is checking the email. If it's empty again, we can never be sure. I don't know. Then it looks for @ then it checks length. I think it's self-explanatory, so I'll just let you read the error messages that it would send. Third, we have validate rejects, which just feels like it's doing the same thing over again. I don't know the reason why I did this, guys. Lol, I'm sorry, but I just remember that I needed it to be so thorough. So it just checks if the @ is in the second part of the string and the dot is in the third. Fourth helper is check DNS. This is the part that checks on the internet to figure out that the domain name the email is using is actually real. This built-in function check DNSR does that. It looks for the DNS name on the internet, so this will actually check the domain after the @ in the email to figure out if it's valid. Then it returns true, if available. Then we have the final function, which brings the above functions together, the one that we'll be using outside the class. So the isValid function goes through the stages. Sanitize, then check if we have a valid structure on the email, then check if we have valid characters that are expected to be found in an email using regex. Then the last step is to check if the domain used on the mail is actually available. Finally, we just return if errors are empty or not, which will give us what we need to know whether it was all successful or it failed somewhere. Now let's go back to the AuthController. Coming back from the MailCheck class, we assign whatever is returned to the result variable. And remember, it was checking if it had empty errors, which means if we had no errors, it would be true here, so it would skip. Otherwise, it would be false. Then it would return a JSON response of failure and a message of what actually happened, which would be one of the messages we all saw in the helper functions from the MailCheck class. Now we can check if the password was given and also check if the user clicked the checkbox to remember them. Now in this line, check equals this AuthService login, email, password, remember me. will remember me. That's where the real login operation is happening. So let's go check out what it does in AuthService. So a lot is happening here, but let's start with the parameters. You can see that it expects email and password just like we gave it in the AuthController class. And the remember is actually optional. By default, it is always false. We execute a joined query to retrieve data from the user table and role table so that we know what role the user has later using the email that we were given. If the user is available, we try to verify the password immediately by checking the hashed password that we have in the database against the password that the user has given us using the built-in function password verify. If that was a success as well, then we start putting the user's data in the session, as you can see. If you remember at the start, we already had a file that was starting up a session and configuring session settings. Now we just call the session variable without calling session start again. We have handle profile. It's in this same class. Let's see what it does. Handle profile receives path ID, first name, and last name. It looks like it gets a profile images path from the path table, And if there is no path or profile image, it uses the first name and last name to get the initials. So basically just trims the name to the first letters. Let's go back. After handling the profile image data, we try getting user permissions. So we do that in this class PermissionService in the helper function load user permissions by just giving it the user's ID. Now let's see how it operates inside. The first SQL query joins role permissions and permissions tables and filters the data using the user's ID. So basically it's getting the permissions of that particular role. What role? The one the user you're trying to authenticate has. The second SQL query gets all the special user-specific permissions that were overridden. The query fetches the list of permission IDs that were overridden for the user from user permissions and simultaneously fetches what those permissions actually are from the permissions table. This will be handy in the future if we want to handle exceptions. For example, everyone in this role can view reports, but deny this one user. Or this user's role can't access settings, but allow this one user. The override type field tells you if that exception is an allow or a deny. The first for each loop takes all the permissions from the user's role perms, and builds a big array. This is just the starting point, what the user can do by default. The second for each loop goes through the special user permissions, user perms, one by one. If it's a deny, it finds that specific permission in the main $permissions array and removes it. If it's an allow, it adds that permission to the main list, just in case it wasn't already there from the role. The third for each loop is just for housekeeping. It goes through the final list and removes any duplicates using arrayUnique, which is a built-in function. The last block saves the final calculated permissions list into a cache, either Redis or the PHP $session. Well, the Redis part, I just added it because I thought I might need it in the future. But if the system would scale to need microservices, this would be handy because it would allow the system or different servers to share the same user sessions with ease. But for now, we will use the session. This is a big performance win, as it means you only have to do all this SQL and PHP logic once when the user logs in, not on every single page they visit. Just to repeat the steps we did after retrieving the permissions, load the base role permissions into an array, apply the user-specific overrides or filtering the permissions by trimming the overrides, and finally, clean up the list, just to be sure. Now let's go back to the AuthService. Okay, now we are getting the agent from the user request. This is basically the browser's identity. Okay, so now this is where we use that Remember Me feature. First, we check if we received a positive Remember Me, which means user clicked on it. If they did, then we are doing something here. What you have to notice inside the SessionService create session parameters is that one has a true and the other does not, which now when I think about it, it looks verbose. But I wrote it anyway, and it works. Deleting is more work than leaving it, am I right? But anyway, we still need these lines down here. So before that, let's check the SessionService create session and see what it does. The helper create session generates a token. And if we see the parameters it expects, it has remember set to by default, which means if that was not given, it will use that false. Next, the condition checks if is false, which means user did not click on Remember Me. If that is the case, we still need to save their session, but this time don't remember it, so we are just going to add an obvious string to the end of the token. But if Remember Me was true, then we use the raw token that was randomly generated. This token is saved in the user sessions table and also returned, and that's what we get back here in AuthService. In AuthService, the token is added into the session and also saved into the browser's cookie jar and set with any amount of duration you need the user to be remembered. Or else you see that we just call SessionService create session, which means the token will be created and saved with that extra obvious string we saw, but we will not save it into our cookie or session. And finally, we log the action, which is another module that we did not talk about yet, then return true. But if all of the above had a problem, then you see we go to the return false. Let's go back to AuthController, which expects this return. So all of that was happening here, and the check variable will take the return value, which we will check in the if condition. So if the verification process went well, we go inside the if statement. We have this line, login attempt service get instance reset retries email, which resets all the retries if the user logs in case they had failed tries. Then below that, it prepares a header which notifies the browser, treat this as JSON, then sends back a JSON format which the JavaScript in the browser must handle. Here, I will just show you how it looks. Here is the line window.location.href equals slash, so you can see slash, which just means go to the root of this website. Remember, we already prepared a session during the verification process, so the website will allow. Otherwise, we made it so that when it detects that there is no session, it redirects the user to the login page. Here is how that is done. Here, found it. This is basically the line here. AuthController get instance is logged in. So is logged in checks for session. We're going to see more about that method later, but it sees that user is not logged in, then it sends them to /login. Anyway, we are done with the login function helper. Let's see what we got more in the AuthController. Oh, it seems we are not done. So login fails. What happens? It checks how many retries that email has. Let's just go check it out how it does that. So it goes and retrieves the latest attempt for the email using desc, then uses this weird expression to figure out what time it is now minus 1 hour. If the latest is older than 1 hour, it means those attempts have expired, therefore reset and start over. Wait a minute, it should start from 1 since we already used 1 round. And it keeps going. If not expired, or no previous attempts, count attempts within the last hour. This will help handle anomalies that couldn't get caught in the first one. So if there are rows of data for this email that are older than 1 hour but were not deleted by the first line, we are going to ignore them. And finally, return the count of rows found, which means that is the number of attempts the user tried. In AuthController, we first check if the user's retries have reached the maximum allowed. If it was, we stop right there and send them a message. If not, we send them a JSON error with a message and count of retries left. Done with the login helper function. We also have a logout function that just probably destroys the session, cleans the session in the database and cookie, then redirects the user to the login page. Finally, the infamous request password reset. This is the function that handles everything when the user clicks on forgot password and requests a reset through email. Let's see what it does. First, it checks if email was provided, then checks if the email is a valid email or else send an error, and finally requests the password reset. Let's see how it looks in reset service. So in the helper function, it first checks if the email is available in our database. If not, it sends a message back, which would be displayed to the user. Then it generates a long string. This is because we don't want users guessing. Attackers can actually just request a password reset, go to the reset page and randomly guess the code, which is why we will limit the number of times a user can retry, but that's for later. Store the code into the table, generate a link to where the user can reset the password, and use my other custom module to send mail. I could have shown that, but it's just too big of a class. Like and subscribe and comment if you want to see my mailing system as well. Finally, if the email is sent or not, it will send back the according email. And we are back here, where the message which was returned is sent back to the client in JSON format, and the rest is front end. We also have reset password helper function. Let's see what it does. Okay, this looks like it is for the page of reset after requesting password reset. So it first checks if the request is a post method for security reasons. It checks session variables valid and email. This is after it has done all the steps and found that the code that was sent with the link is valid. If it was not valid, then we get the error. After that, it collects the values from the post data. It tries the CSRF check just to be sure it is from self. Then it checks the password that user wants to use vis the confirmation password, just to minimize user error. Make sure password is longer than 8 characters for a strong password. Tries to get user using the email that was provided with the code and the link. If user exists, hash the new password and update the user's password with it. If the operation was successful, mark the code as used so that no one tries to use it again, then unset the session values in the operation. Finally, send responses in JSON based on success. Then we have a few more that do nothing but get values from the session. How can remember me work without Autologin, right? This is the function that looks for cookies of the remember me and tries to log in before user inserts credentials. So let's see how it works. Let's go to the main service function. First line, we have check remember me, and it's in here. So let's see what it does. Okay, it first checks if there is a cookie of remember me in the browser. It returns false if none exists. But if it does, it takes the token and populates the session with that token. Okay, let's stop for a minute here, guys. You must know or keep in your mind that we already had logged in, checked that the system should remember us next time. So you closed your browser without clicking logout, go on about your day, then you come back and go to the website. This is what we are working with now when you go to the website for the second time. So that's when this auto login will shine. Okay, now we got that out of the way. Let's continue. So check remember me takes the session token from the user's browser and puts it in the system session. And at the same time, it also tries to get the user's ID using the token. And that is happening in SessionService get user ID from token. Let's go check it out. In get user ID from token, we see that it retrieves the user's ID and the agent from the user sessions table using the token. Then it checks if the agent saved in user sessions is the same agent making the request right now. This is to make sure the same browser that clicked remember me is the one using this cookie now. Also in these lines, we're trying to get the current time. The database tables use Unix timestamps. The reason we use them is to keep time zones accurate no matter where you are in the world. For example, remember when we were checking if a password reset code had reached its 1 hour expiration time? Imagine if the record was saved using the time zone from Nigeria, but the person trying to access it is in the USA. Okay, nothing will really break because the server has its own time, but when it comes to showing the created time, the time the record was made, you might see a 4 to 6 hour difference since the two are in different time zones. But both time zones follow the Unix rule, which means they count their time from the same starting point, a specific number of seconds since the 1970s. This ensures both will have unique but accurate date times relative to their respective time zones. I hope this makes the explanation clearer. Anyway, back to the main point. If the browser was the same browser that checked on remember me, then we return the user's ID. Otherwise, we return false. Okay, and now back to check remember me. You see that's how we get the user's ID. And now back to auto login, which is expecting the session and a user ID. In the if statement, we check if the user ID is available, and if it is, we immediately log that the user automatically logged in. I don't know why I did that at the top, lol. There can always be an error when it comes to database queries. You never know. Let's keep going. We get the user's data from the user table using the user's ID. Then we do the same process we saw earlier in the login, but I see a new one here, register login. Let's check what it does. I see what it does. It just records the user's ID and IP address in the login history table. I think that's it. Then the autologin function returns true, which we already know triggers a redirection to the main page or dashboard. But if the user ID was not returned, it returns false. That case is handled by clearing the cookie in the browser and refreshing the page, which then sends the user to the login page since no remember me cookie was found. Let's go back to AuthController. Finally, my favorite function is login, which constantly checks if the user is currently logged in or has an active session. Let's check it out from AuthService. Okay, the if condition checks if we have a session using user ID. If we do, it doesn't stop there because it might be a corrupted session, so we keep going. We get the user session token in the user sessions table using the user ID we got from the session variable. If the session token was retrieved from the table, we then check if the token contains a string secret. Remember, we saved the token with an obvious string if the user did not click on remember me. This is where that comes into play. Now, if it has that secret string, we just return true, meaning the session exists, but the user didn't want to be remembered. If it doesn't have that secret string, then it takes the session token we got from the user sessions table and compares it with the session token that we have in the system session. You might be thinking, wait, what's the point of this logic? Well, this part is what allows the system to forcefully log out a user. Huh? Yes, whenever we want to log out a user without blocking them completely, we can just click Force Logout. That action changes their session token in the user sessions table. So this code, when it finds that the token in the system session and the token in the database do not match, it goes ahead and deletes the session's cookie, deletes the session, records that the user was forcibly logged out, and also removes the session from the user sessions table. Then it sends the user to the login page after completely destroying their session. And if the session token's matched, it returns true, meaning our user is properly logged in. But we're not done yet. We also check if the user is blocked from accessing the system. If they are blocked, it destroys their session, cleans up the tokens, and sends them to the blocked page where they'll hopefully find the reason for being blocked. Wait a minute, something doesn't make sense here. How would it reach the user blocked condition if it returns after verifying the session? Something to double check later. But for now, if the user was not logged in the first place, no session found, it returns false. So that's all about the isloggedin function. Now let's go back to AuthController again. We have a myRole helper function, which basically retrieves a user's role name if called. If no ID is provided, it gets it from the session. RequireAuthentication just uses the isloggedin function to check if the user is logged in. If not, it sends them to the login page. IsAdmin checks if the user is an admin by checking if the role is not user. So basically, every other role in the system has some level of admin privilege, while the only type of normal client is the user role. So anybody with a role other than user is considered an admin. However, the helper function requireAdmin is more strict. It needs the role name to be specifically admin. This is how we control who has master level access. There are more levels of hierarchy beyond this, but let's keep it simple for now. Finally, the block helper function. This one just gets the user ID from the session. Remember how we checked if the user was blocked? After finding that the user was blocked, we added the user ID into the session. Now we retrieve it and look up the user's data in the blocked user table to find the reason for being blocked. Then we check if a reason was provided. If it wasn't, we add a message saying the reason was not given. And if the user ID wasn't found, we give a message for that as well. Finally, we include the view file that holds the HTML, which will display all the block details to the user. Okay, we're almost done. Next is the BlockUser helper function, and this is where the real action begins. I've been meaning to show you exactly how the permission system ties into actual operations, and this is the perfect moment for it. So let's break down how it works step by step. First, we initialize the permission class. This class gives us access to all the methods that handle permission logic: fetching, checking, and validating whether a user can perform a certain action. Before doing anything, the system checks if the user has permission to execute the BlockUser action. That means that even before any data processing or form handling, the API call itself must pass a permission gate. The system checks the user's role-based permissions, sees if any overrides exist, allow or deny, and then decides what happens next. If the user does not have permission, we immediately send them to a 403 forbidden page and return the corresponding HTTP 403 status code. This is standard security practice to indicate that access to the requested action or resource is explicitly denied. Now let's say the user does have permission. The request passes the first condition. The next check ensures that the request method is POST. Again, this is for security reasons. Sensitive actions like blocking users should never be accessible via GET requests. If the request wasn't made using POST, we send another 403 forbidden response. All right, the user passed both conditions. Now we can actually process the data. We begin by preparing the incoming request data and filtering out any unnecessary or potentially unsafe fields. If the reason field was not provided, we assign a default text like reason was not given, to ensure there's always context stored for the action. Then we call AuthService block, which handles the actual logic of marking the user as blocked. Let's go see what happens inside that function. Inside block, the first thing we do is check whether the user is already blocked. If the user is already in the blocked users table, we simply update their existing record, possibly adding or changing the reason. But if the user is not blocked yet, We insert a new record into the blocked users table with the user's ID and block reason. If that database operation is successful, we also update the user's record in the users table, setting their status field to blocked. The function then returns a status, either true or false, depending on whether the entire process succeeded. Back in AuthController, we check that status. If it's true, meaning the block operation was successful, we log the event and prepare a success message for the user interface. If it's false, we just prepare an error message instead and redirect the administrator to the appropriate page. Next, we have the unblock user function. It's basically the same logic as BlockUser, but in reverse. Instead of inserting or updating, it removes all records associated with that user from the blocked users table and updates the user's status field back to active. It's the cleanup counterpart that restores access to a user who was previously restricted. And finally, there's Reset Password Page, which simply loads the view for the user to reset their password after clicking the email link from the Forgot Password process. We already talked about this earlier, but it's worth noting that this page doesn't handle logic. It just serves as the UI bridge for users to enter their new credentials. And with that, we are officially done with all the helper functions in AuthController. If you followed through up to this point, congratulations, you're a legend. Seriously, you've got some next level attention to detail because this walkthrough has been long and technical, and you've stayed with it all the way through. So guys, there was a video I shared where I promised to share everything, every process during the build, but it's proving to be a bit hard. No, I do have the recordings. I recorded everything during my build, hard to make it into something sensible that you guys can actually watch. It's either too long, out of context, or useless. Hours of records that would need careful nitpicking just to get 5 minutes. And some I just can't tell now what they are about or how to group them into their own subjects worth a video. So that's why I made this authentication system video with already done code, showing it off. This is something that I thought was knowledge worth sharing. I will still be building and recording, but I think this will be the last episode on this particular project. And I hope you're still going to stick around, and if you like this video, like and subscribe. If you have something to say, I will be happy to listen to your thoughts. Let's peek back at AuthService one last time to make sure we didn't miss anything. Looks like everything's covered. Nothing else left to tackle there. And that, my friends, concludes the entire authentication system walkthrough. It's been a full journey. We started all the way from the AuthController's constructor, the singleton pattern, and the show login form method. We dissected the login function with all its pieces, extracting email and post data, the MailCheck class that handles sanitization, structure validation, regex matching, DNS checking, and overall email verification, password verification, and remember me handling. Then we jumped into AuthService's login method, exploring SQL joins between users, roles, and permissions, how password verify works, how sessions are established, and how the system loads user profile data, avatars or initials. We explored PermissionService, load user permissions, including role-based permissions, user-specific overrides, allows deny, 3 key for each loops, building, applying, and cleaning up the final permission list, caching in either PHP session or Redis for performance. Then we dove deep into the SessionService create session, which handles token generation, adding a secret string for non-remembered sessions, saving tokens to the database, and setting cookies for remember me. We covered success paths like login attempt service, reset retries, JSON responses, and redirection to the dashboard, as well as failure paths that handle attempt counting, timestamp checks, and 1-hour expirations. From there, we looked at Logout, which destroys sessions both in the system and database and clears cookies. Then we moved into request password reset, which checks emails, generates secure reset codes, builds password reset links, and sends them via a custom mail module. Then we walked through reset password, including post verification, CSRF protection, password confirmation and strength checks, hashing, marking codes as used, and clearing session values. We even covered Autologin through check remember me and get user ID from token. where the browser's agent string is verified against stored data to ensure the same device is used, along with our detailed look into Unix timestamps and time zone accuracy. We went through register login for recording user history, isloggedin for session validation, token comparison, and force logout mechanics, as well as blocked user detection and redirection. And then we wrapped up with all the helper functions: myRole, requireAuthentication, isAdmin, and requireAdmin. The block and BlockUser methods for permissions and status management, the unBlockUser reversal process, and the reset password page for user-facing password recovery. That's the full authentication system, top to bottom. You've seen how the logic flows, how permissions interact, how sessions and cookies integrate, and how everything ties together securely. Thank you so much for sticking around. If this were a video, I'd say like, share, and subscribe. And seriously, I'd love to hear your thoughts. What worked for you, what could be improved, and what you'd want to see next in future builds.